Good afternoon, students.
Afternoon, sir. Afternoon.
All right, cool. So I didn't start to talk yet. I heard you, but I didn't start to talk. So, as I said from yesterday's class, we just want to practice a few of these questions. I won't bother to teach anything new today. So I stick to statistics of raw data and just do a few questions that we have here on the screen. All right. So that's what I'll do today. So let me come off camera and then we get started right away. All right, guys. So I'm going to start with this one. All right. And what I might do is ask some questions more than what they asked. This question right here. All right. So the question gives us this set of data. It says, in a beauty contest, the scores awarded by 8 judges were these. So these are 8 scores. And since there are only 8 scores, we can analyze them in the raw state. We don't need to put them in a frequency table. We can analyze them as raw data. So we did statistics of raw data. It says, using the 8 scores, determine the mean, the median, and the mode. But I'm going to extend it and do interquartile range and all these things. So remember, as always, the first thing you want to do with the data is put it in ascending order. Hold on a second. Hold on a second. I have the wrong thing up here. All right. First thing you want to do is put the data in ascending order. All right. So I'm going to rewrite the data. How am I getting that? All right. I'm going to rewrite the data and put them in ascending order. All right. So the lowest value is actually the first value, 5.9. Second value is 6.1. And the third one is 6.3. And after that, we have 6.5. The next one would be 6.7, and there are 2 of them, 6.7, 6.7, 6.7, 6.7. We have one more value, which is 6.8. And let's check his 8 values. 1, 2, 3, 4, 5, 6, 7. So I said 8 values, so I left off 8.2. Let's get the 8.2 in there. So make this a little bit smaller and put it in there. So I'm going to put in the 8.2 out here. So those are my 8 scores. All right. So I've done the first thing, the first important thing, which is put them in ascending order. Then I want the mean. What is the mean? The mean is the arithmetic average. So part 1A, I want the mean. And the mean is a mathematical average or the arithmetic average represented by X bar, which is the sum of the values divided by the number of values. So X bar will be equal to adding up all these values. So the 5.9 plus the 6.1 plus the 6.3 plus the 6.5 plus the 6.7 and 6.7 again and 6.8 and then 8.2. I'm gonna shift it over somewhere. All right, and then we'll add 8.2 and then divide that by 8. There are 8 values there. All right, can anybody do this calculation for me? Let's add them up. Tell me what the total is.
53.2, sir.
53.2 divided by 8. And so the mean score divided by 8 and tell me now.
6.65, sir.
6.65. All right, thanks for that. So the median is 6.65. Nice and easy. The next value that I want is the median. So since there are 8 scores, it means that you have to add one more value to the data. Because remember, you must have an odd number of data. So if they give you 8, you need one more to make it 9. One more that you need is the median one in the middle. So I'm going to divide it into half and half first, which is 4 and 4. 4 and 4. And then the median is coming right in between here, which is the average of 6.5 and 6.7. And that is clearly 6.6. That is represented by Q2. That is 6.6. That don't need a calculation, right? So basically that is it. So we can write Papa E at the median Q2 is 6.6. All right. And the position of median can be calculated, but I'm not going to get into that just yet. So we're dealing with raw data. So far, so good? Are they all right so far?
Yes, sir.
Yes, sir.
And then for C, we need the mode. And the mode is the value that occurred most frequently, which is the 6.7. 6.7 was the only value that occurred twice. Everything else occurred once, or appeared once. So the mode is 6.7. That's the mode. All right. Now, before I get to this part of the question, I'm going to put in some additional parts to this part. I'm going to put in a D. And for D, I'm going to ask for the range. Somebody can say what will be the range based on that set of data. What will be the range? How do you calculate the range?
Sir, the highest number from the lowest number.
Yeah, the largest value minus the smallest value. You're trying to determine the full width of the data, or wide the data is from beginning to end. That is the range. All right, that's the full range of the data. So it's basically 8.2 minus 5.9, which is equal to what?
2.3, sir.
2.3. Good. So the range is 2.3. So the range of the scores is 2.3. Then now, part E, I want the interquartile range. How do I calculate the interquartile range? What do I need? What is the formula for the interquartile range?
Sir, Q3 minus Q1.
Q3 minus Q1. So I have Q2, but how do I find Q3 and Q1? What do I do on the data here now? What do I do to find Q3 and Q1? I can say Q1 first. What do I do to find Q1 first?
Sir, the median of the top half.
No, Q1 I said, Q1.
Q1, sir?
Yes. Q1 is the median of the bottom half. You have Q1, Q2, and Q3 in this order. So Q1 is down at the bottom half. It's the median of the bottom half. So you're looking for the median of these 4 values now to get Q1. So since there are 4 values, Q1 is going to be the average of these middle 2. As usual, you have to inject one more term, make it an odd number of terms in the bottom half, and that is Q1. And Q1 is going to be the average of the 6.1 and 6.3, which is 6.2. And over here, that's a similar situation. You're gonna, the 4 values up here, the Q3 is right in between the 6.7 and the 6.8, which is what? What is that value? Between 6.7 and 6.8.
Sir.
Look again.
6.75, sir.
6.75. Clearly, you can add them and divide by 2. But at that time, you don't have to add them and divide by 2. You can look and see the value. Right, so Q3 is 6.75. Therefore, is this value minus this value, 6.75 minus 6.2. So then this becomes equal to 6.75 minus 6.2, which works out to be what? 0.5. All right, that's the interquartile range. And in part F, if now I wanted the semi-interquartile range, what is the semi-interquartile range equal to? Anybody? Remember, semi means half. So it's half of the interquartile range. So it's interquartile range divided by 2. Therefore, it is the 0.55 divided by 2. That's the semi-interquartile range. But understand that?
Yes, sir.
Right. What does that work out to?
0.27.
275. 0.275. All right. So very good. So I've done some range, interquartile range, semi-interquartile range. I did median, mode, and mean. All right. So now let's say to us down here. It's part of the question. It says only 6 scores are to be used. Only 6 of the scores. Which 2 scores may be omitted to leave the value of the median the same? You want the median to be the same. Which 2 values I can remove? Which 2 values, which 2 scores may be omitted to leave the median the same? So you want the median in here to be the same. Which 2 values can remove from the data to have 6 data left, but then the median will remain the same.
Sir, the highest and the lowest ones?
Right. If you take out these 2 values, you just want to make sure that you leave these 2 in the middle. You want the median still to be 6.6. So if you make sure that you leave those 2 in the middle. So basically I can take out this one and take out this one. Now we'll have 6 values left and the median will be in the middle. But theoretically I can take out any one of these 3 along with any one of these 3. Because any one of the 3 I take out, the order of the values will remain the same. These 2 values will still be in the middle. Right? So basically, most persons I think would say take out the 5.9 and take out the 8.2. So that when you have these 6 values left, put them in green. When you have these 6 values left, the median will still be the average of the 2 middle ones in there. So we can remove the 5.9 and the 8.2. So the answer for part 2, most persons I think would say 5.9 and the 8.2. That's the answer. Any questions on that? Any questions there?
No, sir. No, sir.
All right, good. All right, so let's continue. All right, let's do another one, raw data. So it's another one here asking a similar sort of stuff. And this one asks for standard deviation, but this is no longer the syllabus. Calculate standard deviation, only to interpret it, to compare data. So I'm going to do this part. All right, there's a past paper question that they're asking to compare data. Standard deviation data might actually go on it and see if I can find it and see if we can explain how you compare standard deviation. All right, let's go. So on this set of data, they are already in ascending order. Look at it. They are already in ascending order. And I want us to calculate the median mark. How many values are there? 10. 10 values. So since there are 10 values, you have to divide it into 5 and 5. You have to add another value, make it 11. You add the value up to the middle. So divide it 5 and 5. 5 and 5. And then we add the median right in between here, which is Q2. And Q2 is going to be what? Based on those values. The median.
5.5, sir.
5.5. So this is 5.5. And then I want them to tell them, the mean. So the mean, let's do it over here now. The mean X bar will be equal to the sum of the values divided by the number of values. Sum of the values now is 2 plus 3 plus 4 plus 4 again, plus 5 plus 6 plus 6 plus 7 plus 11 plus 12 divided by 10. All right, what does that work out to?
$60, sir.
That's 60 over 10. That is equal to 6. All right, 60 over 6. So the range and the interquartile range will be the same as we just did. All right, same method. So I'm not going to bother to introduce that. So we can still come down and do this probability section. What is probability? Probability is calculated by dividing the number of favorable outcome by the number of possible outcome. Total outcome that you want divided by the total outcome that is possible. All right, so this question says determine probability that a pupil selected at random from the class scores exactly 6 marks. Remember that 10 marks there now. You want those who score exactly 6. Let's write it like this. The probability that X, the score is equal to 6. All right, like that. Is equal to, what's the answer for this one?
Sir, 2 out of 6, 2 out of 10.
2 out of 10, because there are 2 scores there that is equal to the 6, and there are possibly 10 scores to choose from. So it's 2 out of 10, which reduces to 1 over 5. That's the first part. The second part is saying at least 6 marks. What at least 6 marks mean? What does this mean? At least 6 marks. What does that mean?
Sir, 6 or less.
At least means 6 or more. Just think of money. If you must have at least $6 to do something, it means that you need $6 or more. So at least 6 means 6 or more. Don't let the word least cause you to think that it's less than. If you must have at least $10 to do something, it means that you must have $10 or more. If somebody comes to you and say, how much for a party? You're going to say at least $200 means $200 or more. So at least 6 means 6 or more. So what we're saying is the probability that the score is greater than or equal to 6. And what is that now based on the data? Based on the data up here, what would that be?
5 out of 10.
5 out of 10, because there are 5 values that are greater than or equal to 6. And there are 10 total values, so that's 5 out of 10, which is equal to a... Come now? Come now? That's a half. All right, and that's that. Okay, guys, pass good?
Yes, sir.
All right. All right, good. All right, let's look at the next one we're gonna do now. I want us to do one of the on the pie chart questions. I'm gonna do a pie chart question now. Is this one. All right. All right, so this question says, at a career guidance seminar, survey was done, find out the type of career that Form 5 students were likely to take, to choose. These were the careers. All right, and these were the number of students choosing those careers. And they don't give you this one. But they tell us that the total is 1,080 students. The total number of students in the survey is 1,080. And they didn't give us this one. How can we find this one? The value of T. Somebody tell me.
Sir, and the rest of the values, sir, and it's subtracted from the total.
So you're gonna add up all that you know and subtract it from the total to get this one. Quick and easy. So the T is gonna be 1080 minus the sum of the rest, which is 240 and 189 and 216 and 330. All right, guys, hold on. Pause a bit here. I've been invaded in this room. Hold on a second, guys. Hold on a second. All right, students. Sorry about that. All right, so this is what we're going to calculate the value of T. What I give it that? Tell me what the value of T is. What do we get for that?
150.
150? 150?
No, sir, 105.
105?
Yes, sir.
All right. Hope our students check it and get the same thing. So it means that the T value here is 105. I'm going to put 105 in the table. All right, so good. So finish that part of it. The next part now says, the data above is to be represented on a pie chart. Now remember, a pie chart is used to show our whole is divided into parts. So you want to divide, you want to show how the whole group of 1,080 students is divided into these career choices. All right, that's what you want to show. All right, and it says calculate the size of the angles in each sector. So you want to calculate the size in each sector. We're going to call these the sectors, career names. We're going to call them the sectors. So let's calculate them over here now. So first, remember that the total is this. Right? And remember, it's a fraction of the total. And you express that fraction as in degrees. So you have to multiply it by 360. So already know. So the lawyer when the person's chosen law will be 240 divided by the 1080. That's a fraction. This is a fraction of the whole number of students. And you want to see what fraction of the 360 degrees that sector is going to take up. Somebody wrote that out for me, please.
80 degrees, sir.
All right, 80 degrees. And then the next one is the teacher. So I'm going to go and say, okay, the teacher is going to be 189 divided by the 1080 and then multiply that by 360. So you can know the angle that is going to use up, 360 degrees. What is that equal to?
63 degrees.
All right, 63 degrees. Then we have the doctor, which is 105 divided by the 1080 multiplied by the 360 degrees. What is that one?
35 degrees.
35 degrees. And then we have the artist. Artist, who is 216 divided by the 1080. Again, that's a fraction of the 360 degrees in the circle. I want to know what angle they will take up, which is what?
72 degrees.
72 degrees. And the last one, to get the last one, you can literally add up these and subtract from 360. We can calculate just the same. So the person going in sales, let's just write sales. person going in sales is going to be 330 divided by the 1080 multiplied by the total on the circle is 360 degrees. The sector angle for sales is going to be what?
110.
100 and what?
10.
110 degrees. All right. So we have finished that part. And so the next part now says using a circle of radius 4 centimeters. Remember I told you they tell you the radius that they wanted to use. They want us to construct the pie chart. Construct the pie chart. All right. So let me just check if I have something that I can use. Let me just pause the video and see if I can find it. Hold on a second. Because there's a topic that I want to do. All right. So the thing is, I need to get the I need to get all the angles that we had. All right. So let me bring it up here for the time being. On this side of the screen. So where is it? Where is it? Where is it? It's hidden. No. There's no title. This one. All right, good. But it's kind of slow. All right, these are the angles. So let me get back there. Construction. All right, it's already enough. So you basically want to do a pie chart. You want to basically put in these. You want to put in these angles, right? You want to put in these sectors with these sector angles. These are the sectors. Those are the sector angles. They tell us to draw a circle of radius 4 centimeters. All right. I'm going to show you on this device now what you would do. So you need a compass. You need a ruler. That's your ruler. You're going to open your compass to 4 centimeters. So you're going to put the point at 0. Then you open the pencil to 4 centimeters like that. The compass, 4 centimeters. And you lock it. And you move the ruler out the way. I don't need a ruler anymore right now. All right. And then I'm gonna draw my circle. I'm gonna draw my circle right here. So I'm gonna draw the circle. Let's use our red ink. And we go ahead and we draw the circle. You have to hold the point of it. I'll draw the circle. What do I do? All right, good. So then make a circle with a compass, 4 centimeters. So that's a 4 centimeters radius circle. All right. And I bring back my ruler and I draw one line to start. One line to start. That means a different color for the lines. Let's use black. All right. And so I use my pencil. I'm going to draw one line to start. So from the center, we draw one line against the ruler out to the circumference of the circle. And that's the start. Mute your mic, please. Mute your mic. This you have to do this accurately. You know? Have to do this thing accurately. All right. So now I need 80 degrees. Pay attention now. I need 80 degrees. I'll bring up my protractor. All right. You have to position the eye of the protractor right on the point, right there at the center. And then now, remember you can rotate it. You have to make sure that the line passes through 0. Make sure that it passes through 0. So the 0 is over onto the left side of the screen. I don't want to mark it. All right. Okay, we can make it a little bigger. All right. That's it. So make sure that line passes through the 0, the base of the protractor. See it? You put where the 90 and the base meet, you put that on the point. You position it properly so that the baseline coincides with the line passing through 0. on the protractor. The protractor has two scales. It has one that starts at 0 and one that starts at 180 from either end. So you have to start from 0. When you start from 0, you're looking for 80 degrees. So you read up from 0, 10, 20, 30, 40, 50, 60, 70, 80 degrees. I'm going to mark 80 degrees. So let's say I mark my 80 degrees up here. So put a mark for the 80 degrees. But I can see my mark, 80 degree right up there.
Yes, sir.
All right. And then I can move this thing out the way. What it is that I'm now supposed to draw a straight line from the center out to this point. All right. But let's say it is right here. We line it up with your ruler out there now. That will be my 80 degrees. I'm going to put it right here. Good. That's my 80 degrees. That's my first sector. And I can write in my 80 degrees. And write in my 80 degrees. I can put in my law. Yeah, let's just write law for the time being. That's my first sector. Then for the second sector, I need 63 degrees. But I'm starting from that second line that I drew. So I'm going to go back for my protractor. And I have to put it on the point again. And then I have to rotate it so that the baseline again that I'm measuring from pass through 0 right there. But understand that? But understand that? But understand what does that mean here?
Yes, sir.
And then
Yes,
I'm measuring 0 up to 63. Look at the scale properly. Every small line on the outer scale is 1. Every small line on the outer scale is 1. So I'm looking for 63. So 63 would be somewhere around right here. Let's put a dot. That's where 63 is. 60. No, that's not right. That's not right. And I can't erase it, you know, this thing kind of weird. If I try to erase, I might erase everything. So I'm going to put a correct 63. 63 is right here. The second line is 63. I don't want to erase this first one because I might erase the entire thing, all right? So bear with me. So the second one that I just placed there is 63. 60, 61, 62, 63. I'll move this out of the way. And I'm going to use my ruler again and draw a straight line from the center out to that point. That will be 63, but I'm going to position it right here. Stop it right there. That's 63 degrees. I'm going to go, I'm going to write my 63 degrees. 63 degrees. And that is for teacher. I'm just write teach for the time being. I'm just going to write teach. And then from that line now, I need my 35 degrees. So again, go for my protractor. And I'm going to position it on the eye again. I'm going to rotate it to the baseline pass through 0. Again, that I'm measuring 63 from, which is a line that I just used. I know I need 63 degrees. All right. I know I need 63 degrees. No, not 63, 35. The 35 is right here. I'm marking now. 0 up to 35. 35 is right here. Mark it with this. 35 is right there. All right. So I'm going to move the protractor out of the way again. And I'm going to draw a straight line from the center out to that mark, 35 degrees. But I'm going to bring it back right here and up here. 35 degrees. And that one is now for doctor. I must write doc. No, not that. Doc. D-O-C, doc. That angle is 35 degrees. 35 degrees. This thing not so clean, but you get the picture. Then I need 72 degrees. Again, I'm going to bring back the protractor, put the eye on the point again. I'm going to rotate from the last line. I'm measuring 0 from the last line that I had. 0. All right, make it a little small because I want it to see the 72 degrees. All right, so I'm going for 72 degrees now. All right, so 72 degrees is 2 more than the 70. You can see it there. All right, reading the 0 scale again, 0 out. I want 72. So 70, every small line is 170, 71, 72 is right here. Right there, 72. But I give it that. 72 is this line right there, 72. But I go to that.
Yes, sir.
Good. And use a ruler again. And the center out to that point. Wrong line I use. Should have used this one. I don't want to press undo because if I undo, I might erase the whole thing. So just bear with me, okay? So this is the correct line. And then I'm going to stop it right there. So that one, last 72 degrees for the artist. I'm just going to write art. And the angle is 72 degrees. 72 degrees right there. And then this last one now must be sales. I don't have to do anything else. The last one. This one is sales. And the angle is 110 degrees. And that's so clean, but this thing that I use is kind of limited. What I can do it. I don't want to undo. If I undo, I might erase everything. That's why I don't like to put the undo button. But you understand that, guys?
Yes, sir.
Yes, sir.
That's the process, right? Let me see if I'm in the lock. I'm in the lock. Put the undo. See, it's undoing stuff that I don't want it to undo. That's the issue with this app. But anyway, you get the picture, right? You get the picture. That's how all of them, that's how you do all of them basically. It's not complicated. That's how you do all of them. All right, and that was our pie chart right there. All right, so we completed the pie chart over here. Pie chart was completed. All right, so this question down here is asking you for a pie chart as well, I think. It here asks for a pie chart. It's a similar kind of process. Just that now they give the measurement in terms of degrees. They give the measurement in degrees, not in degrees, in percentage, I mean. They give the measurements in percentage, right? So it says a student estimated that 30 hours, he had 30 hours available each week for home studies and for sport. The table below shows the percentage of time spent on each activity, and they give it as percentages. So they give it percentage of the 30 hours. It says calculate the number of hours spent on each sport or on sport. Sport is this one. They give it as percentages, right? So everything must add up to 100. Everything must add up to 100%. And therefore, what is x equal to right here? What is x equal to? What should I put for x right here? To be 100 minus all of these. See? 100
Yes, sir.
minus 30, 20, 15, 15. Now this is 50 and this is 30. 15 and 30 is 80. So actually, yes, this is 20. 20%. Then it says calculate the angle in the pie chart that may be used represent calculate the angle in the pie chart that would be used to represent the hours on mathematics. Now, they already give it to you as a percentage. So you can do it as a percentage of the 360 degrees, you know, to get the angle, you know, a percentage of the 360 degrees. So the angle for mathematics, let me do it right here on the screen. The angle for mathematics, right, would be equal to 20%, which is 20 over 100 times 360 degrees. That gives it the angle, you know. They give it a measurement as percentages. They don't give it to you as hours, the actual hours. They give it to
So I'm going to use that equation.
Huh?
No, I'm going to use that equation, sir.
You're glad I'm using this equation?
Yes, sir, because it makes sense.
Yeah. It's 20 over 100 times the 360. That's a percentage of a circle. What percentage of a circle? It is a 20%. All right. All right. So what would that work out to be? 0.2 times 360. 72 degrees. This will be 72 degrees. And then the language would be 30%. So the language right here would be 30 over 100 times 360. All right, so it will be 0.3. 30% is 0.3 times 360, which will be 108 degrees. And you can do the, so, and simply put, if this is 20%, no, well, if this is 30% and it is 108, it means that 15% is half as much. 15% is just half as much, which is 54. So 15% would equivalent would be equal to 54 degrees. And this will also be 54 degrees. The 20 down here is the same as the one up there. This also will be 72 degrees. And this is 72 degrees. And remember, this is 108 degrees. And if you add up all of these, you're going to get 360. And then you can do the pie chart for this diagram. See, draw the pie chart. They didn't ask us for the actual hours. They gave us the hours as percent. They gave us the ratio as percentages. So they can do that sometimes. Give them to you as percentages of the 30 hours. All right. So you then draw the pie chart just as we did a while ago. All right. But what I want to do, next one says 1 hour in the 30 is shown at random. Calculate the probability that the person is playing sport. All right. Probability that the person is playing sport. That's 20 out of 100. Still 20 out of 100 because these percentages represent the values anyway. So the probability that the person is playing sport is 20%. 20 out of 100 are 0.2. The probability of sport will be 20 out of 100, which then is 0.2. 2 over 10 or 1 over 5. Right? You can leave it as 1 over 5. Probably that is studying math or English, math or language. Math or language means that you have to add them. Math or language means that you have to add the math and the language. So if you study math or language, then that's 50%, 50 out of 100. The probability that you study math or language, the or means that you have to add them, right? One or the other. You have to combine them. That will be equal to 50 over 100, or 0.5 or half. 0.5. 0. It's not marking. I don't know what's wrong with it. Yeah, but it's a bit half or 0.5 for language. So again, language, math or language. All right, so that is that. But what I want to do next, I want to do one of the trend diagrams, trend question. So I want to do one that is asking us to predict what's going to happen in the following year. All right, I want to do one of that one. One that tells us to predict what's going to happen next. So this one says estimate in 2006, 1996, and give a reason. I'm just going to do this part of the question right here. I'm going to do that part of the question. All right, let's go. So this question says, the table above shows the cost of a plot of land over time, over a period of time. It says on graph paper, using a scale of 2 centimeters, represent 1 year on the horizontal axis, and 1 centimeter to represent $10,000 on the vertical axis. Draw the line graph. Draw a line graph. All right, can I get a graph paper? Let me see if I can find a graph paper. All right, let's bring this up over here first. Let's bring this up over here first and then try and get a graph paper. Let's see what we can do. Let's see what we can do. We can find a graph paper. Graph paper is on 2017, I think. Right, it's kind of slow from the video. Right, it's just kind of slow. All right, let me see if I can find graph people on a past people now. 2017.
Oh, that's what I'm leaving it.
This one has graph people on it. Think we can use. There you go. I know my papers. All right, so I got paper here that I can use. All right, so this is the data. All right, and the first thing I want us to do is represent it on a graph, a line graph. All right, so let's go. So first thing I want to put on, the time on the horizontal axis. The time from 1990 to 1995, unless I must use a scale of 2 centimeters to represent 1 year. All right, so I'm going to start at 1990 right here. Let's scale it up. I'm going to put 1990 right here to start. 1990. Then 2 centimeters in 1991. So it's 91. This is 92. This is 93. This is 94. And this is 95. All right, 1995. This is 95. All right, and then it's on the y-axis, you must use 1 centimeter to $10,000. All right, so 1 centimeter is 10. So it means that 2 centimeters is 20. So I'm gonna go and put 20, 40, 20, 40, and this goes up to a maximum of 50. All right, so anyway, 20, 40, I put 60, should be 40. 20, 40, 60. Following instructions. They said 1 centimeter, say, this will be 10, you know. This will be 10, 20, this will be 30. So 40, this will be 50. They did say 1 centimeter to 10. So basically that is it, 1 centimeter to 10. Now I'm gonna scale up this axis, all right? This is my y-axis, my vertical axis. And you might say, well, how come you put 10? Because on the scale here, I'm gonna write cost. I'm gonna write $sign and put a dash and put 1,000. That means I'm doing thousands of dollars. So this is 60,000 and this is 10,000. So I don't have to put the thousands, I put the 1,000 up here. So the values are in thousands, that's what I'm basically saying. And then this is my time axis down here in years. This is my time axis in years, sorry, year. This is the year, showing the year. And then line graph now is plotting points first, and you draw straight lines between the points. So the first one is that in 1990, it was 10,000. So 1990 is 10,000. Pay attention to this question. I'm going to show you something in this question. All right, so 1990 is 10,000. Let's zoom it up. Right here. We're starting right here. 1991 is 30,000. 1991 is 30 right there. 1992 is 36,000. So 1992 is 36. So every small line is 2, right? So 36, this will be 32, 34, 36, 38, 40. This is 36 right here. And so it's this line, this mark right here. But can I get that?
Yes, sir.
But okay with that? Then we'll drop back down to 30, 1993 to 30 right here. In 1994, we jump up to 34. So yeah, well, I could jump back up to 34, which is right here. And then we jump up to 50. In 1995, you jump right up to 50. You can easy to 50. And you're drawing a line graph. It means that you're drawing straight lines between the points. So look at it. A straight line between these two. Use a ruler. And a straight line between these two. Use a ruler. And a straight line between these two. Use a ruler. And a straight line between these two. Use your ruler. And then a straight line between these two. It's called a line graph. Use a ruler. So that is a line graph for the data. All right? So I've completed the line graph section. And it says now, from the graph, determine the period during which the cost of the plot of land showed the greatest rate of increase. When was there the greatest rate of increase? What period was there the greatest rate of increase? Look at the graph. How can we know the greatest rate of increase from the graph? When was there the greatest rate of increase? In other words, the increase was greater over that period, and the change was greater over that period. How can we know from the graph where we had the greatest rate of increase? Anybody can tell me?
Sir, from 1990 to 1991?
You're saying right here. You're saying
Yes.
this period. That's what you're saying,
Yes,
right?
sir.
So
Yes,
what
sir.
about this one? What about this one? And look similar to?
Yes, sir, they look similar.
Yeah,
But
so we don't want to be guessing, right?
yes, sir.
Good. I want to make sure we get it right. So the numbers can help you. The numbers can actually help you. What we can do on the table, you might know, please, we can put in the increases. So the increase from here to here is 20, a plus 20. From here to here is a plus 6. From here to here is a negative 6, so that was a fall. From here to here is a plus 4. And from here to here is a plus what? 16. 16. That's a plus 16. All right. So we went from so actually you're correct. It's the first one and the biggest increase, 20. Is it? Plus 20. It's right here. So you are correct. So the answer for this one, the period during which the greatest increase is 1990 to 1991. No, students, you cannot just say from 1990 to 1991. No, you cannot say 1990. 1990 is a point. You're asking for a period. It has to be between 2 years. And you also cannot say 1991. You cannot say 1991. You have to represent it because you're talking about this part of the graph. This part of the graph spans 1990 to 1991. So that's what you have to answer right here. 1990 to 1991 is the period which you had the greatest increase. Next part now, watch this now. State the year during which the cost of the plot of land decreased. Which year did the plot of land decrease? Which year did the value and the cost of the plot of land decrease? Which year? During which year? Come on, students. During which year? Come on, nobody can answer that. Which year did the plot of land? Which year did the plot of land decrease? During which year did the plot of land decrease?
1993.
92, sir.
No, you cannot say 93. Let me.
Sir, like 1993, sir. That's what I mean. That's what I mean, sir.
What you said?
I meant 1993, sir, but I just said 93.
No, you cannot say 1993.
1992 to 1993.
You have to say 1992 to 1993. Let me explain why I can't do that. Because a lot of the times, the business year does not start at January. So you cannot say 1993. Or 1993 is just a point on the graph. You don't know when in 1993 they took this, they finalized and give you this figure, you know. You don't know when. It could be in December, but it could be in June. Some businesses, the business year is from in the middle of the year to the next middle of the year and the next year. Not everybody business is January to December. Because a business year, most times, depend on when the business first started. So if a business started first in March, then their business year will start March. If a business started in August, then their business year will start in August. So it's not every business start financial year is January to December. And therefore you have to be explicit with the year that they're talking about by looking at the graph. It decreased between 1992 to 1993. So that's what you have to say. You cannot say 1992, and you also cannot say 1993. It decreased in the year between 1992 and 1993. Be explicit that way. Don't just say 1992 and don't just say 1993. Don't assume that the period from here to here is from January to December. You don't know that. You don't know that. So you cannot say that. You specify by saying 1992 to 1993 as represented on the graph. So it's 1992 to 1993. Is the answer for that one. All right. I want to do this next. All right, but watch me now. I'm gonna ask you a question now that they didn't ask on this one, that I might ask on another one. Listen to me carefully now. What feature of the graph did you use to determine? They don't want to say you got it from the table, you know, that this was the highest one, you know, the 20, you know. They wanted to get from a graph. Look at the graph. Remember, statistics, you can interpret things from a graph. So what feature of the graph can be used to determine when we had the greatest increase or greatest decrease or something like that? Somebody tell me. What feature of the graph can we use to determine when you had the greatest increase? What feature of the graph can we use? Tell us that. What feature of the graph can we use to answer this? What feature tell us this? What feature use? What feature did we use to get this information? Somebody tell me. Anybody tell me? What can you look at the graph to know when you had the greatest increase? Anybody can tell me that?
Sir, what is this, sir?
What feature of the line graph can you use to determine the answer for this question right here that I've circled in purple? In terms of when was there the greatest increase or decrease? Or when was there the greatest increase in this case? What feature of the graph we used to know when we had the greatest rate of increase? What feature of the graph?
Y-axis?
No.
Sir,
What feature of the line?
Brandon said the difference, the coordinates on the value y, the y value.
The difference in the coordinates and the y values.
Yeah.
All right. So what they're really looking for, guys, is the slope and the length of the line segments. The lines with the greatest slope, the ones that slope upwards the most, have the greatest increase. And also they will be longer. If you notice, this line is longer than this line and longer than that one. Also, the slope of this one, the longest one, is more than the slope of this one. It's more vertical. This one is the most vertical of them all. That one. Right? The one that had the longest one.
The steepness
slope,
of the slope, sir.
the slope. Steepness, you use the word slope, I use gradient. So you can say the gradient and the length of the line segment. Not only the gradient, but the length. The one with the highest gradient will also be the longest one. You know why? Because the horizontal change for all the lines is the same. The horizontal change for all the lines is the same. So once it is steeper, it also will be longer. So is the slope and the length of the line segment is what you use to determine this. The slope and the length of the line segment. So that's what you have to write. Slope and length of line segment. That's what you have to use. Slope, I can use gradient, and slope and length of the line segments. You compare them. The slope and the length of the line segments. But mostly the slope. Mostly the slope. Remember, another word for slope is gradient. Another word for slope is gradient. So the gradient. So the one with the highest gradient increase the fastest. The one with the lower gradient increase not so fast. And the ones with negative gradient, you know that they fall, they lose in value. So these are what you use. These are the features of the line that you use to determine where you had the greatest increase or the greatest decrease. So far, so good? So far, so good?
Yes, sir.
Yes, sir. Yes, sir.
All right, I'm gonna watch out the video and remember these things, you know. All right, so watch this now. I'm gonna mark this last part in green that we're gonna do. So I now want to estimate. So the word estimate. Estimate the value of the plot of land in 1996 and state one reason for your estimate. So that's what we're doing now. So from this information that we have, we want to estimate what the cost of the plot of the land is going to be in 1996. And we want to give a reason for our estimate. Anybody have an idea how we can estimate what 1996 is going to be? Based on the table, what is really from the graph that I wanted to use. I'm going to show you that we can also use a table to do it. Anybody can tell me?
Sir, can I try?
Yeah, man, go ahead now. So let me mark 1996 on the graph. So 1996 is going to be right here. You can see it? 96. And you want to know what the sales and what the cost in 1996 is going to be. And the estimated from the information that you have so far. Go ahead, let me hear you. First thing, gonna be more or less. You expect it to be more or less.
Sir, I think it's gonna be more, sir. Like there's going to be an increase.
Why do you think it's gonna be?
Sir,
yes,
because sir, because of the previous year, sir, there was a constant increase in price. So
but there's a decrease right here.
Yes, sir. But right here. Yes, sir, but the 3 years right before 1996, sir, there was increase. So that's what I think, that it would be increased.
So what about that value? What do you think will estimate that value?
I'm not so sure about that, sir.
Yeah. Into that in the last class, you know. All right, so firstly, if you look at this graph, you can see that the cost of land generally is trending upwards over time. You can see it, you know. It's trending. It started down here and it started trending up that way. So because the graph generally, so even though it have like a hiccups along the way, and like a hiccup here and like a flat section almost there, right? Even if it came down here and then went back up, over period, generally looking at it, just looking at the overall thing, you can see that it is trending upwards, trending upwards overall. That's the first thing. So you expect it to increase, all right? Because it is trending upwards if you just look at the graph. But how do you estimate what the increase would be? You can determine it from the graph, and you can determine it from the values in the table as well. And I wanted to pay attention to this because when this question was asked in CSEC, a lot of people couldn't do it. And they might ask something like that again. So to estimate what the next value is going to be, it's very simple. You draw a straight line from the beginning to the end. A straight line from the beginning to the end. You use a ruler and you draw a straight line from the beginning to the end. Listen to me carefully, you know. And after I draw that line, you extend that line for one more year. Extend it up. The same line that you draw from the beginning to the end, you extend it up for one more year. And therefore, you expect that in 1996, your sales will be somewhere around here. And then you read that value off the graph over there. Read it off the graph over here. Because I'm not using a ruler, I'm going to show you also how you can do it by calculation. Now, what is the reasoning behind this? What is the reason behind doing it this way? This purple line that I've drawn, there, it basically represents the line that you would be on if you're increasing. There's an overall increasing from here to here, is an overall increasing. But this purple line that I've drawn from the beginning to the end represents the line that you will be on if you're increasing by the same amount each year, to start at 10 and still end up at 50. So in other words, if you're increasing at the same amount each year, instead of increasing in an opposite way, doing all kind of things, then in 1991, you'll be right here at this point right here that I'm marking now. In 1992, you'd have been at this point right here. In 1993, you'd be right here. In 1994, you'd have been right here. And in 1995, you'd have been right here. So these points that I've marked are the points that you would be on if you're increasing the same amount each year. That same amount of increase each year is an average of the increases. So what you do, you average out the increases from year to year. So if I look at these increases on the table, pay attention now, you know. If I look at these increases, the 20 and the 6 and the -6 and the that and the 16, those are my changes. Not just only increases, changes. I shouldn't just say increases. Those are my changes from year to year. If I average out these changes, then I can apply the average of those changes as my next change. But understand that? If I average these changes, I can apply the average. These are my changes. These are my actual changes. And I'm trying to determine what the next change will be to take me over to 1996. That's what I'm trying to find out, you know. 1996. I want to know what my next change would be to get to 1996. My next change is going to be average of these changes, average of those changes. And that is how you know what the next value is going to be. Because in order to know what the next value is going to be, you need to know what the next change is going to be. And the next change is the average of the changes you have so far. You call that the average rate of change, the average of the changes. You want to know what the next change is going to be from the 50 to what? What will the 50 change to get me to the 1996 score? To know what that next change is going to be, you average out the changes that you have so far. there are 1, 2, 3, 4, 5, 6 values. If there are 6 values, then there are 5 changes. See, there are 1, 2, 3, 4, 5. So you average those 5 changes and you apply that average as your next change. That is what this line represents. The average change. If you're increasing by the average change, you would be on that purple line. The graph would be on that purple line, because then it will be changing by the same amount each year. And you would start at 10 and still end up at 50. So this is a graphical way to do it, to draw a line from the beginning to the end and extend the line. But the calculation way to do it is to calculate the average of these changes and apply that average as my next change. Let me calculate the average of the changes over here. Let me calculate over here so you can see. So my average change, and put it in red. My average change, I'm trying to know what the next change is. My average change in the value is equal to the changes that you have divided by the number of changes. So you have a plus 20, you have a plus 6, you have a negative 6, you have a plus 4, and you have a plus 16. There are 5 changes. I am averaging those changes divided by 5. I am averaging those changes. So you work that out and you divide by 5. What is the average change? I'm going to show you on the graph just now exactly what I'm saying. And that it is true. So it's basically it's 8. So the 8, the average change is 8. It's 8. I remember it's thousands of dollars we're talking about. Right? It's thousands, right? So it's really 8,000, right? So it's really 8,000. But I was saying 8 for the purpose of the graph. I remember working in thousands, remember? In thousands. Oh man, working in thousands. So it's really 8,000. 8,000. So the next change is gonna be 8,000. See? The next change is gonna be 8,000. So from 50, what will be my next value? My estimated next value? Tell me now. My average changes are plus 8. So I would have to add 8 more to this. So my next value in the table, or to put it in there in red or in blue and purple. My next value in the table, if I were to extend the table and estimate the next value, it will be how much? 58,000. 58,000. 58,000. Understand that, guys? I got what did I get?
Yes, sir.
Because the line,
Yes, sir.
because the line is so straight. Because the line is so straight, that's why I'm gonna get more than thing there, but it's 58. So if I were to come back on the graph and draw the line with a straight line, it will come to my 58. Maybe somewhere there if I extend line like that. If I extend that straight line. So draw a straight line from the beginning to the end. It represents the average change, average rate of change. If you're changing by the same amount each year, you'll be on this purple line. And so your next change can be obtained by extending that line. And then now you come out to 1996 down here. You read up on the graph, read up on the graph, read up on the graph like that. And then you read across like that. Read right across like that. And you would get your 58 from the graph, the written graph paper. And use a ruler and draw it to get the 58 right here. And I can show that if you increase by 8 each year, you're going to end up at the 50. Watch this. Put them on in red for you. So if I start at 10 and I increase by 8, then this will be 18, won't it? Remember, it's 18,000. Again, that will be 18. Right? And if I add 8 more, it should be 26. This one will be 26. I'm sure I'm still end up at 50. If I add 8 more, it should be 34. This one will be 34. So instead of 30, it will be 34. This one, 34. And if I add 8 more, this will be 42. This one will be 42. And then if I add 8 more, clearly I end up at the 50, which is a real point on the graph. I would end up at 50. And so to get the next one, what you do? You add 8 more. And that will take me up to 58. 58. I think you can remember that, guys. So let me summarize it for you. What you really want to know is what the next change would be. So you can determine the next value. You want to know the next change. Remember, the values are changing from year to year, you know, and you want to know what the next change will be. So you can know what the next value is going to be. What you do, you average the changes that you have for the previous years in the data. Take the average of those previous changes, average out the changes, and you apply that average change as your next change. That's what you do to estimate the next value. Because it's that thing about rate of change and the value is changing. Because what you're doing, you basically assume that the average change will remain constant. So that's the reason. See, don't you know? When I'm asking for the reason, this last one now, that is asking you for the reason, mark circle in red. This last one down there is asking to state one reason for your estimate. We assume that the average change will remain constant. This 8 is the average change of the changes. And you assume that it will remain constant. Remember, this is 50 or 58,000. So that's what you say here. We assume the average, so not the word average, change, the average change in cost. I don't need to write it. The average change in cost, write it here, so, will remain constant. It means the same. For, can't write no more. Can't write no more, then gone. Students are still there? Still there, everybody?
Yes, sir.
Yes, sir.
Okay. Then gone. I don't know what's happening now, right?
Yes, sir.
Pen gone. What's it there now? All right, come back. Right, so it remain constant for the, then gone again. Oh, so it's up. Even problems. Wait. Remain constant for the next year. That's what you do. Guys, I want you to look over this and remember this explanation. Very important. That's how you do it. So graphically, you draw a line. If the question says use your graph to estimate the next year, you just draw a line from the beginning of the graph to the end of the graph and extend the line to the next year to estimate what the next year is going to be. Calculation is supposed to give you the same answer. Calculation will give you the same answer. Or you do the calculation. Remember, the objective is to know what the next change is. And you apply the next change to the last value that you have. The next change is the average of the changes you have before. So they are not going to give you the changes. You have to work out the changes as I did here. See, I had to work out the changes. These are the changes from year to year. And I want to know what the next change is. And so I average those changes and apply the average change as my next change. So you apply that change to the last value. The last value is 50,000. The average change is 8,000. So I'm going to apply an 8,000 to the last value. And so my estimated value for 1996 is 58,000 because I'm estimated that it will change by 8,000, which is the average of my changes so far. Do I need to explain it anymore?
No, sir, I get it, sir, I get it.
Get it. All right, good. And I want you to watch over the video. All right. Don't think I have any more questions on this that I want to do just now. So I want to take the next couple of minutes and talk about the standard deviation thing. But I want to see if I can find a question that it came and now is either, I think it's January 2019. I think it was on a January paper. Let me see. Yeah, I'm sure it was a January paper. And it might have been January 2019 that paper came. Some people want to help that. Want the paper too. Yeah, so January 2019, I think is the year that set that standard deviation thingy for the first time. Came onto the syllabus, and that is what you're required to do. You didn't need to calculate it. People doing advanced have to be able to calculate standard deviation. And there's a formula to calculate standard deviation, and the formula will be on the formula sheet. All right, so let me see. Here is the statistics. Question really gave a table. Some boys and some girls. Where is it? This paper. And this is not this paper. Yes, it is. There you go. Hey, Mr. Shaw, knowing papers, you know. Tell you. Shaw, knowing papers, I know which year, which exam come on all these questions, come on all these things. These are statistics questions. What I wanted us to focus on is a part of it that asks about standard deviation, compare some standard deviation. See there, considering the standard deviation, compare the performance of the boys and the girls using the standard deviation. So I want to use this as an example to show you how you can use the values in standard deviation to compare, to make comparison. All right. So let's do this. All right. So firstly, what is standard deviation? Standard deviation is a measure of how the values in a data varies from the mean value. Very important. It's a measure of how the data varies from the mean value. All right, so let's say I have a mean value here, X bar, that's my mean value in the middle here. All right, should I put a value? Put a value. So let's say my mean value is 20. Let's say my mean value is 20 marks. And these are marks, right? 20 marks. And let's say my lowest value from the 20 marks, from 20, my mean value of a set of data is 20. And the lowest value is 10 or 5. The lowest value is 5. And let's say the highest value, so the mean is 10, and it goes from a low of 5 to a high of say 40. I mean, these are nice values. Say go to a high of 35. Keep it balanced. Just keep it balanced for the purpose of the explanation. 35. That's one set of data. So this is data 1. So this is data 1. Data 1. Yeah, another set of data 2. And let's say just for convenience, for data 2, we're gonna make the mean also be 20. We're gonna make the mean also be 20. But from 20, this one is gonna go up to 30 as a high, and this one is gonna come down to 10. All right, so from the mean, the first set of data varies by positive 15 to 35 and down to negative 15 to 5. And for data 2, this one varies by a positive 10 to 30 down to negative 10 to 10. Which one of these two sets of data? Let's say that these are, and they have some other values in between. You have some other values in between. But the mean is 20, and the varies to a low of 5 and a high of 35. Here again, the mean is 20 for a set of, another set of data. It varies down to a low of 10 and goes up to a high of 30. Which of these two sets of data you think would have the highest standard deviation? Standard deviation, let's call it, let's write ST for standard deviation for now. ST, standard deviation. I think delta is a symbol that they use for standard deviation. This symbol here, delta. I think is what they use for standard deviation. Sometimes they use S. S.
So what is standard deviation again, sir?
Standard deviation is a measure of how the data varies from the mean. That's what it is. It's a measure of how the data, we have a set of data, like we have a set of data here, in this example, in this illustration that I'm, so what I'm saying that it might have some other values in here, you know, like it might have 7 and 18 and 19, it might have 22 and 28 and 31. So you have all these values, but I'm just picking out the mean, and I'm picking out the lowest value and the highest value for the purpose of illustrating. So these are the data values. I'm leaving out those data values because those are irrelevant right now. So standard deviation is a measure of how far the data varies from the mean. So how close or how wide the data is from the mean. From the mean. So the higher the variance from the mean is the higher the standard deviation. The lower the variance is of the data from the mean on average is the lower the standard deviation. Right? That's what we're looking at. So if the mean is 20, look at the first set of data. The first set of data, I'm just using that and said, okay, on average it varies from 5 to 35. The second set of data, I'm saying on average, it varies from 10 to 30, and the mean for the two of them is 20. Which one of them would have the higher standard deviation and the lower standard deviation?
One, sir.
The first one would have the higher standard deviation. The standard deviation for this one will be high. And the standard deviation for this one will be low relative to each other. So this one might be a value of 15. Standard deviation is 15 because the values vary on average by 15. I'm just going to use that as an average, as an example, right? Just for illustration purpose. Not exactly quite like this because it's really the average variation from the values, right? It's the average variation from the value, not the last value, not from the mean to the lowest value and from the mean to the highest value. It's the average variation from the values in the data, all right? And down here now, this will be low because the variation would be 10 from the values. All right, on average, it will be 10 from the values. So this one would have a higher variation from the values, so higher standard deviation. This one would have a lower standard deviation. So the question is, if I didn't show you this data, and I tell you, okay, for data 1, standard deviation is 15, and for data 2, the standard deviation is 10, and I say to you, compare data 1 and data 2. What could you see? What could you see? If I say, if I erase everything inside, you know, if I erase everything inside here, so no, everything, and I take out everything inside here, so I don't show you none of those figures, delete that. All I give is that and say data 1, standard deviation is 15, data 2, standard deviation is 10. And it's two similar kinds of data. Two similar kinds of data. But it's like two football teams, for example, or two players. And the standard deviation for one player is 15, or two teams, two football teams. And the standard deviation for the players on team A Our team 1, in terms of scoring goals, is 15, and the standard deviation for the players on team 2 for scoring goals is 10. And I say, okay, compare the performance of the players in team 1 with those in team 2. What are the things you think you could say based on those standard deviations, one being 15 and one being 10?
So repeat the question.
All I'm saying is that if I give you this set of data, if I tell you that for data set 1, if I tell you that for data set 1, standard deviation is 15, and for data set 2, the standard deviation is 10, and I say compare the 2 data sets based on those standard deviation values. What do you think you could say?
Sir, that data 1 has a higher standard deviation than data.
You can't tell him that as the answer because it's obvious. So you can't tell him that what is obvious. And that the one. They want you to interpret it. So you can't tell him say one higher, have a higher standard deviation, one have a lower standard deviation. Because that is obvious. 15 higher, 15 more than 10. They can't tell him what is obvious. You're not asking that. Interpret the information. Look at the score, look at the values. Yes?
Sir, would it be that team 1 had more goals than team 2?
They don't must have more goals. It don't have to be that they have more goals. They can have the same number of goals overall. All right, so let me not punish you anymore. If you notice, in data 1, if you notice in data 1, let me take out these red lines. In data 1, the values vary more from the mean than in data 2. The values in data 2, they are closer to the mean. So what the words that you use is that these are wider, these have a wider variation, or the data is more widely spread, more widely spread, wide, the data is wide, widely spread, the data spread out more from the mean, more widely spread from the mean. These are the keywords you have to use. The data is more widely spread from the mean in data 1. Copy these down and shift them down. Not there. See, the data wider from the mean. I go from 20 all the way down to 5 and from 20 all the way up to 35. So the data is wider, more widely spread from the mean. See that? In data 1. In data 2, you would say something like the data is more closely spread, closer than the first one, more closely spread from the mean, And you have to say this, you have to say from the mean, it's a comparison from the mean. So standard deviation is a measure of how closely or how widely this data spread from the mean. So what it means therefore as well, is that the values down here, one that are closely spread, the values are closer to each other. So the lower the standard deviation is, the more close the values are to each other and to the mean. If the standard deviation is low, is a low value, it means that the values in the data are closer to each other. It's like all of the scores are around the same. The scores are around the same. So if it's players on a football team scoring goals, it means that all the players on the team scoring around the same amount of goals. Like some score 7, some score 6, some score 8. 6, 7, and 8 is where they're scoring. 6, 7, and 8. While on the other team, with the data is more widely spread, you have man scoring 6, you have next man scoring 1, you have next man scoring 15. they vary widely from each other in the performance. If the standard deviation is high, if the standard deviation is high, the values are far apart from each other. If the standard deviation is low, deviation means that the values don't deviate from each other a lot if the standard deviation is low. And it is in reference to the mean. So the values do not deviate far away from the mean as much if the standard deviation is low. If the standard deviation is a high value, it means that the values or the performance values are varying or deviating far away from the mean. The data values are not close to each other if the standard deviation is a high value. If the standard deviation is a high value, the values are not close to one another. The values are wide from each other. The performances are wide apart from each other. If the standard deviation is a low value, it means that the variation is less. Low variation. But you hear me still?
Yes.
Yes, sir.
All right. So that's what I need you all to pay attention to. Hold on a second. So this thing on my data will be, I didn't know. Can't believe that I get the whole class on my data. Anyway, get the entire class on my data. Instead of on my Wi-Fi. Anyway, that's what it is. All right. So remember that, guys. I want to play over the video list what I've said. So let's look at this question now. Let's look at this question. Let's see if we can actually answer all of it. Even though it's not it's not raw data yet. Let me see. People sending out. All right, let's look at the question. All right, let's look at it. The question says, it's almost like raw data. It says the incomplete table below shows the results obtained by 200 boys, and 250 girls in a Spanish exam. So in a Spanish exam, you have 200 boys and 250 girls in the Spanish exam. All right, and then these are the grades. So grade 1, they show the grades for the girls, that. And here they show grade 4 for boys and so forth. But remember, you know, the total is 200, so they want to show some of them. So these are missing. All right, those are missing. And for the girls, these are missing. All right, and then now they also gave us these standard deviations, 8.2, 6.3. So this one is a higher value, high standard deviation relative to the next one. This one is lower, a lower standard deviation. So they're really looking for which one is high and which one is low. So the one with the higher standard deviation means that the boys' scores are wider from each other. Or the boys' scores are wider from the mean score. That's what the 8.2 mean, because it is higher than the girls. The girls' scores 6.3, so their scores are closer to each other and to the mean. So the scores of the girls are more closely spread. The scores of the boys are more widely spread from the mean. The scores of the girls are more closely spread from the mean. So the girls, like all the girls performing almost the same. The girls more consistent with each other in terms of the performance. The performance of the girls are more consistent with each other, while the performance of the boys are less consistent with each other because the standard deviation is higher. Understand? But anyway, let's answer the question. It says, a girl is chosen at random. Determine the probability that she got a grade 1. A girl got a grade 1. So the girls is 62 girls. 62 girls got grade 1, and there were 250 girls. So what is it? The probability that a girl equal a grade 1, and set up like that equals what? I can't write it out, you know. Probability that a girl scores grade 1. That a girl scores grade 1. And write it out. Probability that a girl scores grade 1 is equal to, talk to me now, what is it?
62.
Huh? Go ahead.
62.
What one? Probability is a fraction. Probability can be more than 1, you know. Probability is the number of actual outcome out of the number of possible outcomes.
Yes, sir. 62 over 250. Good.
Probability must never be a value more than 1. Probability like a chance. So it's always a smaller figure out of a total. If a probability is 1, it means that you're certain that something is going to happen. You're 100% sure. When the probability is 1, you are sure that something is going to happen. So probability is like a chance thing. So it can't be more than 1. So there are 62 girls who get grade 1, and that 250 of them had the opportunity to get grade 1. 250 of them could have gotten grade 1. But only 62 got it. So the number of favorable outcome out of the number of possible outcome, it was possible for 250 of them to get it. But these are the only ones that got it. 62. So it's 62 over 250. And whatever that worked down to is a probability. Usually leave it as a fraction. Usually leave it. You can leave it as decimal still, no, but I think they like when you leave it as a fraction. All right. So if you put it in a calculator, it will give you as a fraction in lowest term. With the 62 over 25, and you're gonna use calculators, give it to you in lowest term. I think it worked down to
31 over 125.
Yes. 31 over 125. All right. Nice and easy. 1 mark for that. That's easy. Next part says, what percentage of the boys in the exam achieve grade 1 to 3?
0, sir.
Huh?
0.
Why is it 0? Why is it 0? Why is it 0? Why jump and say 0? Because they don't show nothing here, sir?
Yeah.
Distance to the table is incomplete.
Oh.
In addition to that, they only show 38 and 200 of them there. You know, so it means that all that happens that they don't fill out here so yet, and they don't fill out here so yet, because this not up to 200 either. This not up to 250, you know. It means that these values here are missing. This one missing, this missing, this missing, this missing, this missing, this missing. Come again. I want to know the probability. You know what I'm saying? Calculate the probability, percentage, calculate the percentage of boys who scored between grade 1 and 3, from grade 1 to 3. So the ones who scored from grade 1 to 3 are all
38 over 200. Wait.
Think, the percent, listen to the question, ask the probability. It says it's asking you for the percentage of the students who scored from grade 1 to 3. The percentage of them.
So, sir, is it going to be 162 over 200 times 100?
Exactly. Because you have 162 total right. The total students were the right here, so is 200 minus 38. See? 200 minus 38 is the number of students we get between grade 1 and 3. Just that you don't know the actual what them get. But you know that is that amount there. 162 students in that section right there. But understand that?
Yes, sir.
You understand? Other students understand?
Yes, sir.
Yes, sir.
Good. And I want to know the percentage of them who get that. Is 162 of them get between grade 1 and 3? So the percentage is 162 over 200 as a percentage multiplied by 100. What the percentage is that? 81%. Just 81%. Right? So see here, so down here, so 62 of them out of the 200, not 62. Yeah, 62, 162. Yeah, 162. 162 students get between grade 1 and 3. 200 students in all. Percentage-wise, multiply by 100. That's the percentage of them. And that is 81%. 81%. So 81% of the students got between grade 1 and 3. 81%. Come on, man. Let's not just jump to answer a question. Make we read and make sure so we interpret what the question is asking carefully. These things easy, you know. But we have to make sure that we read carefully what the question is asking. Don't just blurt out things that we think them are ask. Read carefully. Make sure you understand what the question is asking. All right. Question asks for percentage, don't give them probability. Give them what they ask you for. All right. Don't use to know. It says, considering the standard deviation on the table, compare the performance of the boys and the girls. So you just want to say something in your own words. Remember, you know, the standard deviation for the boys. Standard deviation for the boys is 6.3. For the girls, is
No,
8.
sir.
Yeah, man,
So
the boys
isn't
was
it the other way
6.3.
around?
Nope. Oh, you're right. You're brilliant. All right. So it's 8.2 for the boys and 6.3 for the girls. All right, good. So remember, the larger standard deviation simply means that the scores of the boys vary wider from the mean. Remember, you always have to say from the mean. Standard deviation is about variation from the mean. Variation means the difference from the mean. The scores of the boys vary more from the mean than the scores for the girls. I know the scores for the girls vary from their mean. In other words, the scores of the boys are wider apart. The scores of the girls are closer to each other. So the girls, like the girls performing close to each other. So like all of the girls, they might do good. But in the case of the boys, some are do good and some are do bad. In the case of the boys vary in terms of the performance.
So the girls have them collaborative study groups, sir.
Yes, and they're more consistent. The girls are more consistent with each other in terms of the performance. That's what it means. So you just have to write something to that effect in your own words. But the key thing to say is that the words like widely spread, closely spread, to the mean or from the mean. You have to say from the mean. You have to say from the mean. Standard deviation is about a deviation from the mean. So the mean score of the boys and the mean score of the girls. That's what we're talking about. All the scores of the boys vary from the mean score of the boys. How the score of the girls vary from the mean score of the girls. They do almost have the same mean, you know. The mean score of the boys and the mean score of the girls do have to be the same, you know. The mean score of the boys might be 50 and the mean score of the girls might be 70. But it means that all the girls them getting near 70 together. But then the boys now, even though their mean score is 50, some of them I get far more than 50 and some I get far less than 50. And even though the mean score for the girls is 70, all the girls coming close to 70. That's how we can look at it. So they don't have to have the same mean. This is not to say they have the same mean score. The mean scores might be different, but the variation from the mean score for the boys is more than the variation of the girls from the girls' mean score. Think you understand that, guys?
Yes, sir.
Yes. So, all right. So I want you each to write in your own words the explanation for this and send it to me. 1 mark. Send it to me WhatsApp. Think you can do that? So let me say what I would write. And let me write what I would write. Something like something. And if I write it tomorrow, I might say something different. It just all depends on how I construct the sentence that way. But I must write something that says the scores of the boys vary more widely from the mean score of the boys as compared to the scores of the girls. Now we'll go further and say that is the scores of the girls vary more closely to the mean score of the girls when compared to those of the boys. Something like that you have to say, what I just said. Do I need to write it?
Yes, sir. Write it, sir.
Why I must write it? Why must I write it?
Sir, so I can use your answer as a reference.
No, I use my answer. I usually put it in your own words. Put it in your own words. I'm right, so I can write something. Depend on my work code. Depend on how me to write it. The grades is grades, right? The grades are the performance. That's a grades. It's a performance. We're talking about the grades, right? All right. The grades of the boys. Talking about the boys now. Are more mute the mic, please, mute the mic.
Sorry.
Widely. This one bigger, you're gonna use the word widely for this one. Are more widely spread from the mean score of the boys, or if we can say from their mean score. From their mean score. Talking about the boys. THEIR, from their mean score. In comparison to those of the girls. So the grades, the grades of the boys are more widely spread. Key things to say. More widely spread from their mean score. Have to say from the mean score. And it is in comparison to the girls. And I can go further and just build on it and say the grades of the girls, talking about the girls now, just to be explicit, are more closely, because this smaller is a close for this one. So this one is wide. And this one is close. The values are close because it's smaller. The values are close to the mean. This one, the values are wide from the mean. So for the girls, the grades of the girls are more closely spread. From their, talking about the girls now, their mean score. In comparison to the boys. Keywords to use. Again, more closely spread from their mean score. Keywords. You're seeing how the data is spread from the mean score of the boys and all the data is spread from the mean score of the girls. That's what standard deviation is. How the data, how close is the data to the mean score? If a standard deviation is a high value or a higher value, it means that the data is more widely spread. The values are wider apart from the mean score. If the standard deviation is a small value, it means that the values are not varying so much from the mean score. The values are closer together and closer to the mean score itself. But you have to say it is in relation to the mean score. Standard deviation is about variation from the mean score. And when I say variation, I mean how different from the mean score are the values. How different from the mean score are the values. If the values are far different from the mean score, then the standard deviation is going to be a higher value. If the values are generally close to the same value as the mean score, or the mean value, then the standard deviation is going to be a lower value. I've spoken it and I've said it multiple times, multiple different ways. All right, I want to see your own words, the explanation for this standard deviation question. Compare the boys who do 8.2 standard deviation with the girls who do 6.3 standard deviation. Write it out for me and send it to me on your own words. Everybody, use your own words and write the explanation for me and send it to me. That is the end of class today. Very good?
Yes.
Yes.
Yes, sir.
All right. So on Wednesday, my plan is to go on to the next part of statistics, which is grouped and ungrouped data. So the ungrouped data, they don't set questions on ungrouped data a lot. But we're still gonna do some work on it. But the most set questions on group data. Group data is where the most set questions done in CSEC. All right, hard ever getting a question on ungrouped data, rarely. All right, so we set 100 questions CSEC, maybe 5 of them is ungrouped data. Most times is group data, they set questions on, and occasionally they'll give us some raw data. So therefore, what we will learn in the ungrouped data, we make it stick. You're not going to see a lot of questions on ungrouped data if you're working from past paper. All right, so that's the plan for Wednesday's class. Okay, guys?
Yes, sir.
Okay. All right. So,
Yes,
bye.
sir.
You are.
Yes, sir.
Watch
Bye,
out.
sir.
You know the program. Watch over the video. Read all the examples and send me the explanation for that variations question, that standard deviations question that I put up on the screen. The boys have a standard deviation of 8.2. The girls have a standard deviation of 6.3. Send me your interpretation of those values in your own words. Make sure you have to say widely spread, closely spread from the mean. Those words must be in your explanation because standard deviation is about how widely, how closely spread data is from the mean score of the data. All right, can I say it again? Bye. See you all on Wednesday. Bye, everybody.
Bye, sir.
All right, good.